Today we're going to create a Diagrid structure that projects onto any 3D surface, and the Diagrid must be made out of straight line elements, and the floors are shown in horizontal lines. So this 3D surface can be manipulated and the Diagrid will update itself to follow, and it will always maintain a straight line for all the elements. And I can also just move the whole line and that's going to create more of a curved shape. So it's curved both horizontally and vertically. And just a reminder, you can get more tutorials like this under this section on our website. We've got quite a list now, and you can also download some of the free tutorial scripts in this section here. And feel free to have a look at some of our other services if you're interested. We've got conversion, smart tools, reinforcement, etc. Okay, so I'm just going to start by typing point, as I often do, at 0, 0, 0. And then I'm going to just press enter and it does point again. This time I'm going to go 500, 0, 6000. Enter again, 2000, 0, 12,000, and enter again, 3000, 0, 1800, 18,000. Okay, now I've got those points. I'm just going to type Polyline, join those 3 points up, and enter. Then I'm going to select that, type copy, and I'm going to use this top window. I'm just going to move it up by 6,000. And then 12,000, and I'm holding down shift while I do this. And then I'm just going to grab this middle one and move it slightly to the left by 1,000. Hold down shift again, just so that we know it's lined up. Okay, now I can start my grasshopper. I can use the curve component. I'm just going to maximize this. We only need the one screen now. It's easy to work like that. I'm going to add this curve, set a curve. Now I'm going to go down to manage curve collection and add an item, the second curve, and do it again for the third curve. So I've now got 3 curves. The reason I did that is that I want those in a specific order. If I just grabbed them all and inherited them, they might be in a different order than what I need. Okay, so that's our 3 curves. Then we're going to do control points. That gives us points of the polylines. Then NURBS. So this will turn these straight line polylines into actual curves with these as the control points. So it's going to best fit a curve to those points. Now we're going to create our surface. So to do this, I'll just make this a bit bigger. You've got surface frames is the best one. There's also surface points, but frames gives us more flexibility, which I'll describe later. So if we put, oh sorry, I've missed one step. If I go disconnect that, the NURBS, I have to loft them first. And this is loft here. So this is going to create our surface through our curves. And they're in the right order because I added them like I did before. So I need to flatten this list because they're a list of three lists of one item each. If I flatten them, that creates our surface. And then before I skipped ahead, the next point is to split it up into frames. So now that we've got our lofted surface, which best fits to these curves, I'm now going to split it up. Now to show you how it looks with the points, there is divide surface. So it's doing the same thing. The only difference is that this is doing planes and this is doing points. So if you want to see the points, you can use that component. If you want to see, we actually want the planes. So I'm just going to do some panels to control this. I'm going to do 3 in one of them. Copy and paste that, and I'll do 4 in the other. I'll just keep them going at the same time for the moment. Now I actually want it the other way around. I want 4 in the top, 3 in the bottom. So that's just dividing up our surface. Okay, so now we can start making the Diagrid. Now this involves manipulating lists on trees. So firstly I'm going to simplify this tree so that it's got 5 branches with 4 items in each branch. Now what I need to do is I've got to offset. To create the diagonals, I've got to shift these lines over and shift the columns upwards. So to do that, I've got to use 2 different components. One shifts the branch and one shifts the items within the list. So to shift the branch, we've got relative item. If I plug that in there, and our offset is going to be 1. I think it needs a specific format, so it needs it in the curly brackets, which is the tree. It's the way it refers to branches. So now we've got our original tree and our tree where the points have been shifted into the next spot. So that's one way, and then the other way we just use the old shift list. So I'm going to take A, I'm going to shift it by -1. going to take B, shift list, and it starts off shifting by 1. And then we have to turn wrapping off on both of these. So to show you what it looks like, if we use the points, if I just copy and paste this up, and I simplify that, that's one set of points, and that's another set of points. So if I connect both of those two together, it's going to create the diagonal lines that we need in one direction. So now all we have to do is do the other direction. So I'm just going to copy, paste. B goes to the top, A goes to the bottom. There we've got a diagonal pattern. And lastly, if I just use line, I'm going to join the A and the B points together to create one of the levels. And the next step will create the other level as well. Now, of course, there is other ways of doing this, and you might come up with a better way of doing it for your project. But like anything, there's multiple ways of doing this. So now what I'm going to do, the way I'm doing it in this particular instance, is I'm going to project these lines onto the surface. Because as you can probably, you might be able to make out, because the lines are all straight lines and the surface is curved in 3 dimensions, these points here aren't going to intersect. So that's the reason I'm projecting onto the surface. In fact, I'll just show you how that might occur. If I move this point out further, the surface is going to update itself. And you can probably see this point here. That's not going to intersect. So we want all these lines to intersect in this particular example. So what I'm going to do is I'm going to use the project component, project onto a BREP, because this is a BREP, the surface. And I'm going to project the first set of lines. And our BREP we've already got, which is created from the loft. Now the direction, it defaults to Z. So it's going to try and push upwards, project upwards until it hits the surface. So you're going to get some crazy lines. But what we actually need is we need to work out, and this is particularly important if you have a complete circle, a vector which points away from the surface. So this is one way of doing that, and it's not 100% accurate, but it's pretty much, say, 95% there or more. So what I'm going to do that is I'm going to deconstruct a plane. Deconstruct plane. Now, as I was saying before, the reason I used frames is because of this. So if I because we're using frames, I can deconstruct them. And when I mean frame, it's got an origin and a direction associated with it. And if we want to see that, I can just use this vector display. The anchor is going to be the origin, and the vector, the normal is Z. So you can see these little arrows are the direction that the vector is pointing to, and its point at which it's created is the point it's pointing to. So what we want is we want to project our lines in the opposite direction because they're all on this side of the shape. So that's pretty easy. I'm just going to reverse that vector. And then I'm going to tell that I'm going to project in that direction, the reverse direction. Now if I turn this line off, you'll see that it's created some curves which are perfectly, which are in the direction that we want, and they fit the surface perfectly, unlike these lines which are away from the surface. So that's what we want. And of course we want it in for both of them. And I'm going to turn these lines off. And then the last few steps are, I'm going to turn these back from curved lines into polylines. But the first thing we need to get is the point at which they're intersecting, which was the point of that little exercise there. So under intersection, you've got curve, curve. So you're going to take the first set of curves and the second set of curves, and that gives us our intersecting points. Okay, so the last step, as I was saying, polyline. I want the start and end points of this list, which is these lines. And I want to simplify all this before simplify these outputs. Control copy paste. Okay, now we can create some polylines. So I'm going to use the first point of the line, which is going to be, just take this one for example here, the end point, and the middle point, which is the intersection. So we're going to start with start, hold down shift, I want the intersection as the second input, and the end point, holding down shift again, as the third intersection. So now if I turn off these curved lines, you'll see that these are straight lines and they intersect that point, and that point. So same again for the last, for the curves in the other direction. I'll just turn this one off. Start point, middle point, holding down shift, last point. Okay, now the second last step, I want to get a line between these middle points because that's going to be our story, our floor height in this particular example. So what I need to do, you might notice that these lists are in there's three at the 0 tree branch, 3 at the 1 branch, 3 at the 2 branch, and 3 at the 3 branch. So I've got 12 values, and I've got 4 branches and 3 items within each branch. So I'm just going to simplify that by using this trim tree, and that just cuts the branches off. And I want the intersection points. So what that's done is it's cut the branches off and just given me, cut the leaves off and just given me the branches. So 4 branches with 3 items in each. Then because I want to use shift list, I'm going to flip this matrix. If I did it the other way, it'd turn vertical columns. Use shift list, and then line. Oops, wrong line. Line between 2 points. And you'll notice I've got that classic unwanted last line, and that's because I need to turn the wrapping off. So there we go. Now I'm just going to unpreview some of this stuff, get rid of the points. What other points have I got? I don't want those. Turn those off. Can turn the vectors off now. I've seen what that's doing. Turn these points off, and this is probably the last one there. I'll keep the surface, and I'm just going to pipe these Diagrid members. Change the radius to 100mm diameter pipe. And there we have it. So the Diagrid's made out of the pipe, and the floors are at the lines in this case. Thanks for watching this structured parametrics video. Leave a like or subscribe if you found this useful, and we'll see you in the next one.